Hello everyone. So this is an example problem like number 10 on your Energy 1 homework. Anyway, a 4 kilogram object is on a spring that is compressed 1.7 meters. If the spring has 5 joules of elastic potential energy, find the spring constant. Alright, so this here, 4 kilograms, that's going to be our mass. Alright, and the object is on a spring that is compressed 1.7 meters. So that's a distance. We know that's going to be our x as far as this elastic potential energy is concerned. And then we know that the spring has 5 joules of elastic potential energy. Well, since this is joules, we know that it's going to be a type of energy, but it's going to be elastic potential because it tells us that. And because we have a spring involved, so we know that's going to be an elastic potential type of energy. And it wants us to find the spring constant, which is K. So what we do is first we write the equation for elastic potential energy, which is elastic potential energy, but you might have seen this written differently, but it means the same thing, right? Here we're going to express it with a capital P, capital E, and a little EL. And that is equal to 1/2 the spring constant K times x squared. So we're going ahead and going to plug in our numbers. We know that the energy here is 5 joules of elastic potential energy. And then we have our 1/2. K, our spring constant, is what we're trying to figure out. Find the spring constant. And we know our x, how much the spring is being compressed, is 1.7 meters. So this will be 1.7 squared. Alright, so first things first is we're going to take care of this exponent, and we're going to square our 1.7. So 1.7 squared is 2.89. So we could say that 5 equals 1/2 our spring constant times 2.89. Well, our next step is we want to get K by itself. So we could multiply these two numbers together and then divide to get K by itself. So what we're going to do is multiply 2.89, so 2.89 times 1/2, which you can either write that as a 1 over a 2, or you could write that, I guess this won't do delete, we could say 2.89, and we know that 1/2 is the same as 0.5. And either way, you're going to get the same number. So we know that 5 equals 1.45 times the spring constant. So to find the spring constant, we have to get 1.45 on the other side. Well, since this 1.45 is being multiplied to K, we have to divide it to get it away from our spring constant K. Well, 1.45 over 1.45 cancels out, and then we're left with our spring constant K is equal to 5 over 1.45. So we'll go ahead and plug that in, 5 over 1.45, and we get 3.45. So our spring constant, actually we'll use this nice teal color that we're matching. Our spring constant equals 3.45 newtons per meter. And that is the spring constant for this spring system here.